Okay, so let's dive right in. The first part of a 3x5x7 scramble, classic scramble I'll call it, as opposed to parity-free scramble, is we solve it based on the base puzzle, and the base puzzle is a 3x3. So I'll put this color as the top and this color as the bottom, or both of these as the top and bottom, because it's the part of a Fisher puzzle that's the least variated. All right, so the first part is putting in the cross. So here's a white edge, and this is a supercube aspect, so in solving it, I have to bear in mind that the rotation of the center has meaning. So although this is my white center, is that white? Yeah, white center. Here's a white edge. This has to go to the green and red. So here's a green and red center over here, and you can see this is upside down. So turn it here, double turn, and move it back. Boom. Okay, so that's the first part. Now I'm looking for the long white pieces. All right, here's another one here. So, and this belongs here, but this is rotated wrong. The orange and green, so move this here. Green goes to the side. This moves in. And this is placed up, like so. Okay, here's another one, which goes to the red and blue, and that's here. So I'm going to move this into position, move this up. Okay, so we've got this in, we do have this in, and we have this in, and this one is not rotated correctly, as you can see. So bump it out of the way. Move this in like this, move it here, and bring it up. Okay, so we have the cross. What's interesting is this is the first cross that actually looks like a cross. It looks like a classic cross, and that's because of the shape of this, and these are long shapes. Normally you have to just see the cross by color. Now you can see the cross by shape as well. So this is a true classic cross. All right, so the next part is putting in our edges. Corners rather, see, I already made the mistake, perspective mistake. So these corners are basically these corners. They look like little triangles. But they're one color, there are two colors actually, instead of three colors. So this lines up with the green, so that's going to be over here. Between these two greens doth lay this one. So turn, and up. So there's a long stretch of distance between the edges and the corners here. So here's another green one. This goes where the orange goes, which is right here. Turn, and turn. So this is good. This is good. Find the other. I thought this was an edge for a second, but it is not. Something completely different. A corner, but it's not. Okay, this goes here, here. Let's turn this in and up. So far, I'm really digging the movement. And now finally blue, the Twisty Text blue. All right, let's get this lined up. Oh, interesting. Turn, and up. All right, so now we have basically our first side. Ignore all of this. We have our first side. We now turn it upside down, and we have to get the edges in. Now we got to be careful because, well, we have to make sure the edges are lined up with the right centers. Now, which center is our 5 layer and which is our 7 layer? Well, it's not going to be clear to me right now as to which it is. Now, this one appears to line up with these, so this is going to be our 5 layer, so therefore these really long ones must be our 7 layer. We have to bear that in mind as we're putting these edges in. Okay, so the edges are these long pieces here. These are the edges, well, that look like centers. So this does belong here, but in what direction does it go? Well, this is our 5 layer, and this is going to be the 7 layered version. So it's going to go like this because you have two pieces here that are on this side and one piece that are on this side. The one piece is going to line up with this. If I do it wrong, I'm going to have the wrong edge in the wrong layer. So let's go ahead and put it in. Turn. Now, if I didn't realize that now, I'm quite sure that when I would think I was done with the 3-layer solve, I probably would have found myself still bandaged. And the whole key with the 3-layer solve is to take bandaging out. Okay, so this makes sense because this has one piece which matches up with the 5-layer side, and this has 2 pieces, so I have to bear that in mind. So here's an orange, and this orange is going to go here. But I'm going to make sure that the 1 piece is lined up with a 5-layer center, and the 2 pieces before the center is lined up with a 7-layer. So I didn't realize that until now, but I realize now too that if I didn't make that realization, I would have been very confused. Which in a puzzle like this is not hard to get confused. Turn, turn, and turn. Okay, so now imagine if I turn this upside down. If this was upside down, now first off, in a Fisher puzzle, remember how this had rotational equivalency? I wouldn't know it. I wouldn't know it, so I ended up with this apparent parity, but it's actually the fallacy of false equivocation. In this puzzle, I would know it because there's a difference between these layers. And that difference I can see based on the number of pieces that are on either side of this edge. So here, I'm not going to run into that false equivalency because I can tease out the difference between the layers. Does that make sense? If not, well, it does, sort of. So in other words, does this go in this way or does it go in this way? In a classic Fisher cube, I wouldn't know, but here I can see the difference between the other edge pieces on either side of this large edge piece. The other, I guess, yeah, edge pieces. This has 1 before the center, this has 2. So now I know the direction, and I know that the 2 has to land in the 7x7 layer. How do I know which one it is? Well, I count the number of edge pieces before the corners. 1, 2, 3, 4, 5. Here is 1, 2, 3. So I know I need more of these pieces lining up with this center and less of these lining up with this center. So this to here is the correct orientation. So that's pretty cool. And turn. Now I've got to be careful that I'm not dragging the wrong layers with me. Okay, so this is in, this is in, this is in, and this is in. And we understand this configuration to be correct. I have an edge and 1 center here, edge, 2 centers. Now here's the thing, this only has 1 center. So this is rotated incorrectly. Now, I know this is rotated incorrectly. I don't even have to go to the next layer to see that. I know this is rotated incorrectly. I don't even have to go to the next layer to see that because I see that this is the 7-layer edge and there's only 1 piece here. There should be 2. So you can see it's already bandaging. Here is the 2. Now, if you look up here, notice this is rotated correct, this is correct, this is correct, this is incorrect. And you'd say, oh, parity or false equivocation. Which one is it? Well, I can't just randomly pick one to flip like I could with this. I know it's this, and I knew that even before looking up here. So I didn't even have to do that before knowing that this is wrong. So that is one characteristic, unique characteristic about the Fisher version of the 3x5x7, which is interesting. If anybody wants to write the definitive book on the structure and function of these puzzles, a Gray's Anatomy version or Netter's version of puzzles, that's what you would say. But you won't get into a Fisher false equivocation because it's well known, the orientation should be known as you're solving the puzzle. And down. Okay, so now all these are in. I've got my 2nd layer, I look here, and you can see there's no apparent parity. You got 2 rotated correct and 2 wrong, so we're going to do F, U, R, UI, RI, FI. Well, I'll do it like this just to keep FI. Okay. So you can see we've got our cross. You can tell because it really looks like a cross. And now we're going to bring this in. So it's interesting to understand the structure as well as the function of the puzzle, the difference between parity and false equivocation, how fissures work like that. Now if I do this, you are, you are I. I think it would be interesting to do something of a literature about the structure and function of a puzzle. Okay, that rotates all these up. Now what I do is I line up corners. These are corners. This is lined up. This is not. This is not. So I see these two are lined up here. These two have to swap, so I'm going to do that. 2R, U, 2R, UI, 2R, UID, 2R, UI, 2R, U, 2R. Now I would say that the fact that this doesn't shapeshift to 90 degrees adds to the challenge of the perspective with this puzzle. Okay, so now I put the centers in. Generally speaking, I have at least one in, and I have these. Then I just do 2R, 2U. I could move this, but I won't. I'm going to move the whole thing. 2R, 2U, 2R, 2U, and then 2RU, 2R, U, 2R, 2U, 2R, 2U, 2RU, 2R. So you can see the movement of this puzzle is a pure joy, very playable. Boom. Okay, so this is my 3x3 solve. The 3x3 solve is now done. And although it looks less scrambled than it might look here, I'll point out that a lot of these edges are not lined up. They're not shape-shifted, so it looks like it's okay, but even though it's not shape-shifted, on this it would be shape-shifted and it would look still very chaotic, which means I have to skew my attention to it to understand that these edges are not in the right place. So the next thing that I do is I have to take the bandaging out. To take the bandaging out, what happens is I have to make sure that all edges are down. All edges are like this, at least flat. Maybe this is here and this is here, but at least flat. And then I have to get them in the right place. So this is where my perspective becomes something of an issue. I believe I had trouble with this when I was doing this guy over here. And I don't imagine I would have any better of a time of it. So what I want to do first is get these edges flat, get them down. So I'm going to start with the 3x3 part of it, well, the 5x5. So this edge here, I'm going to start with these on all sides. So this is up, and I got to get it down. So what other edges are just to the side of these edges that need to come down? Well, these, I've only got two. If I only have two, then I sense a red bull, but I got to get them next to each other, if I can. I might be bandaged to the point where I can't. Aha. All right, so I got a little lucky with that. I can move that there. Now I try to maintain my 3x3 solve as much as I can. So I'm going to keep that here. Okay, now as long as I can move this and this, I can red bull this and bring this down. That's 2R, 2B, 2U, whoop, L. 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, and then we have LI, 2B, 2R. Okay, so understand what that did. It flattened out all of these 5x5 portions of the edges. So then I do the same thing here. What I try to do first is I see what can be shifted down and if I can just move it down. The problem is that they're all bandaged. They're bandaged because of, well, this. So if I move it, now I have to have 7 by 7 edges in front of me. So what I need to do is I need to get these in the right place. These are long edges. They don't belong here, they belong here. And the easiest way to do that, they don't belong, so they belong on this side. So I see that these two don't belong here, they belong here. So if I have two that are opposite each other, two that are opposite and two that are opposite, then I can simply switch them like so. And now I'm going to take these, make them parallel to here, and I'm going to swap them. Swap these two that don't belong here with these two that don't belong here. So cur splat, and I'll simply move it back. So as you can see, the bandaging was taken out. Now I've got a couple others that are incorrect, but let's see. Okay, so now the bandaging was taken out here. If I have three that are up, doing this move will take that down, but I've got two that are up and two that are not. If I can add another one, then I can take it down. Now this is bandaged here, but if I were to take this, and if I were to move this, because either I have 4 or 3, in which case I can just move it 90 degrees, or I have 2, then I have to red bullet. So if I move it like this, I simply go pow, and it's done. Now I want to maintain my 3x3 solve, so I'll move this in here, move this in here. Now, there's a variety of ways and configurations that each scramble can give you. That's why I like playing with these puzzles over and over again, because that was fairly easy to flatten these. But it might not have been that way, because I might have ended up with far more bandaging. But you saw that if only 2 are up, I red bullet down. If 3 are up, I move it 90 degrees, and then I'll just have 1 up. And then I'll see if I can get it to a position where 4 are up and I just switch it. If 3 are up, then I move whatever I can, end up with 2 and red bullet down. So there's a variety of different variations I can hit that. So we're not completely unbandaged yet. So this is fine, that's good. This is fine, that's good. This is not fine, and that's because these edges obviously don't belong here. This belongs here, where you have to have 2 from the center. 1, 2. These just have 1 from the center. So let's see if I can start pairing these. If I can pair them opposite each other and exchange it from the other edges that are opposite, then we're doing good. So I've got 1 here, and what else doesn't belong? All of these are good except this. So what I actually have, and what I'm going to do, is I'm going to move this up here so they're in the same layer. As you can see, if I look down here, all these edges are in the right place. All of these are in the right place, this is in the right place, this stands out like a sore thumb, so does this. I identify this not by the shape change, it doesn't look like this where you can tell that they're wrong, but just by the bandaging that's here. So what I need to do is I need to find a way to swap these two. Now how do I do that? Well, it was easy if I had 2 that were opposite each other and 2 of another kind that were opposite each other. I just moved it to opposite layers. Move them in line with each other, like this, swapped them and moved it back. So how do I do this? Well, the best way to do this is I have to pair edges that look like each other with each other. So this is not paired with an edge that looks like itself. It's got to be paired with this. Even if it's in the wrong layer, if I pair them, then I can put them together, and then I can start pairing them with the proper center, and then I can move it accordingly. So all that means is if I do a corner swap, but I include this as my entire corner, this will go here and be paired with this. This will go here and be paired with this. The problem though is that these two will swap, so will these two. But this wants to be here, and this, well, wants to stay here. So I'm still going to pair them correctly, because this will go here to be paired with this. This will go here. But then these two are going to swap. This will be where it wants to be. This will be here, not where it wants to be, but at least paired with a similar edge. So I'm pairing like edges with like edges. So it'll still work. So I'm going to go 2R, U, 2R, UI, 2R, turn, turn, 2R, UI, 2R, U, 2R. This is classic 3x5x7 strategy. This comes back here. It did break my 3x3 solve a little bit, but let's take a look what happened. So you see all these edges are paired. Don't worry about the corners. you're going to see that this edge and this edge are both paired. And you're going to see this edge and this edge are both paired. These are not correct in conjunction with each other, but now I'm going to swap these two edges. I'm going to swap these two edges so that all these edges can be paired correctly. So 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, and 2R. Okay, so what you see are these edges are all paired together, these edges are all paired together, but what I need to do is I need to put back in my corners. Because as you can see, this corner doesn't belong here. What I need to do is I need to swap these guys. But you can see these edges are all paired. These are, don't worry about this, and these are, don't worry about this. So we're going to go ahead and move corners back to our U, to our UI, to our UI, D, to our UI, to R, U, to R, and this moves back. Okay, so taking a look at what we have, you may think, oh, it looks kind of bad, but it really isn't, because this is all lined up. The corners are fine. These are in together, these are not. So what I'm going to do is I'm going to have to take this pair, this triplet, and flip-flop them with these triplets. These will come here to be with its brethren here, and these will come here. So we've got 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Okay, so we're that much closer to where we need to be. So let's take a look at what we have. These are all paired, these are all paired. I'm having a hard time with these. These three are wrong. So these three and these have to exchange. So we're going to do that. And I'm slicing it here, I'm making sure I'm just exchanging these. So I'm just going with these three. So 2R, U, 2R, U, so it's this, not here, but here, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Move this back, and lo and behold, we are unbandaged. We did it. Now, that might have been a lot to follow if you're not used to this kind of a solve, but basically I was pairing these guys, and I was drawing a difference between what I was calling corners and what I was calling edges. But it did work, but let's see if we've maintained our solve. We might not have. What we can see is our, well, let me see. See where we are from the standpoint of our centers, because it's not going to be like this. It would have to be like this. Okay, so good, 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 and good. All right, how about these guys? These seem okay. This is wrong, and this is wrong, but that's okay. They just need to be exchanged. This center is good. This is not. And this is good. So all I got to do is go like this, do an opposite edge swap. These will swap back. That's going to be 2R, 2U, 2R, 2U, 2R, 2U. Move this back to here. I think. Yeah. So these are lined up. These are good. These are good. We have maintained our 3x3 solve, and we've completely unbandaged the puzzle. So we are well on our way. Now, that was a lot more complicated than it might have seemed. I did run through it kind of fast, but believe me when I tell you, it was almost a completely different puzzle than this, just by its structure. So the next step that I do is I got to get these down, and I do that by basically first putting in these corners, these centers rather. So I put in all of my 5x5 centers. So I should be able to put all of these guys in. That's not this, it's got to be just off center here, and I've got a bunch over here. Okay, so the way that this should work is with sliding U techniques. So let's see if I can maintain my perspective. So this moves into here, like so. I slide it from the left to the right, then I move it down, like thus. Slide it back to the right, move it up. Slide it back to the left, move this up, and move this back. Okay, in that way, this is now in. We can move this back to here, and just to get a perspective, move this back to here. Okay, the other red is directly here, so move it in. So you can see it's correctly placed. Slide it to a more leftward position, move it down, slide it to a rightward position, move it back up, slide it back. If you get lost once, it's partially re-scrambled. So I have to keep my concentration up. Okay, so these are now fine. Greens and blues. Well, this blue can go here, so move it in on the left. If I make this my U, slide the U to the right, down on the right. Slide it back to the left, up on the left. Slide it back to the right. Now you may wonder, why do I keep saying it as I'm doing it? What I've had people tell me is that after seeing the videos for a while, if I keep saying it, they say it finally clicked what the heck I was talking about, what the sliding U technique really is. So to those that have gotten it, great, congratulations. To those that still need help, I'll continue to do that. So basically I'm going to move this to here, put this in a U position, move it in from the right, left rather, as you can see, slide it to a right position, then down on the right. Slide it back to the left, now I go up on the left, slide it back to the right, now I go up on the right, and slide you back into position, and this is in, and nobody got hurt. Okay, so there's a green one. I can simply find where I need a green one. There's a couple of places. I'll do it here. So down on the left, slide it to the right, and then down on the right. Slide it back to the left, up on the left, slide it back to the right, up on the right. So this is the easiest part of the solve. In many ways even easier than the 3x3 portion because I don't have to worry about perspective. Okay, I've got a couple more here. Now, there's something that you may have noticed, is I'm saying this green is the same as this green. Is that really correct? Because what's interesting is that in this puzzle, these two greens are equivalent to each other, but these two pieces are equivalent to these two pieces. So these two are not equivalent to each other, but these two are. In this case, it's pretty easy to see how this piece is not equivalent to this piece. Yeah, this piece is not equivalent to this piece, but in this puzzle they are. Might this cause trouble for me? It might, because some of the algorithms that I use probably swap these two pieces, but it's of no worry to me. What if one of the algorithms that I'm going to use at the end will swap those two pieces and will always put me in a position where I appear to have two out? So that is the difference between that puzzle and this. Different pieces are equivalent than in the normal 3x5x7. Does that make sense? Basically, these two pieces are not equivalent, which is equivalent to these two pieces, which are equivalent. I'm saying that these two pieces are equivalent, which is equivalent to, to these two pieces, which aren't. So I'm so used to algorithms that know the difference between these two, but don't know the difference between these two. If I apply those algorithms, I may find myself with these two pieces always being needing to be swapped. So I'm moving this one in. So it'll be very exciting to see what happens with that. If that made sense to you, then you know what I'm talking about. If it didn't, well, you will come to find what I'm talking about very shortly. Well, I don't know how shortly, but okay, so now I'm going to move this piece in. After this is in, well, the next step after I put these centers in is the hardest part of the entire solve, and that's the fun part. That's the exciting part. That's the one that I don't know how prepared for I am. Okay, so as you can see, these pieces that are just off center are all in. And that's what I was looking for. So basically that's equivalent to these two and these two. So I've just placed all of these. These I can't do quite yet. Okay, now I want to do these centers too. Still doing the 5x5 centers and not the 7x7 centers. Still sliding U techniques. So maybe I can do 2 and 1. I can. So I'm going to move this up, which puts these two in. On the left rotation, slide it to the right. I'm going to move these two to the right, slide it back to the left. This goes back up, slide it back to the right. Those two will come back, and boom. That leaves one more, which is well positioned. If I go like this, okay, one more white over here. Move it in from the left, slide it to the right, move it out from the right. So these are 2 L's and 2 R's. Easiest part of the puzzle. Boom. Okay, so there's that. Now, we've got all these centers in, of course all these centers in, these. So the next step is, well, basically flattening this, putting this where it's supposed to be.